In this lecture, we'll understand the hydrostatic force on curved surfaces. So let's try to understand this. So here, this is the rigid surface here, and this is the rigid surface here, and here this is the curved surface. Okay, and here there is a free surface, and this is the width of the plate. So this is the width. Okay, now this is the curved surface here, and the force which is acting perpendicular to this curved surface, that is this force. So that's why, as it is a curved surface, so there is a two component. One is vertical component and one is horizontal component. And if you want to calculate the resultant force Fr, that is equal to under root of Fh square plus Fv square. And if you want to calculate the tan theta, that is equal to Fv by Fh. So Fh, that is equal to summation of Fx, and Fv, that is equal to summation of Fy. Okay, so this is the basic about the curved surface. Let's try to understand this. So here, hydrostatic force on curved surface. So hydrostatic force on curved surface act in different orientation. So the resultant force can be defined by horizontal and vertical component. So horizontal component, it is the hydrostatic force on projected area of curved surface in vertical plane. Its point of application is the center of pressure of corresponding area. So this is my handwritten notes. You can download it from the description. The PDF format is available on the description. Like, share and subscribe my YouTube channel. So and for vertical component, after that we will understand the horizontal component and vertical component. Let's try to see what is written in this book. Vertical component, it is the weight of the liquid above the curved surface up to the free surface, and its point of application is the centroid or center of gravity of the corresponding volume. Note, if there is no liquid above the curved surface and hydrostatic force act on the bottom side, so that vertical component from the bottom side can be defined by the magnitude of the weight of an imaginary column of same liquid from same free surface, and this force will pass through the centroid of an imaginary column in upward direction. So let's try to understand this. So here, this is the horizontal component. Let's focus on the horizontal component. So here there is a horizontal component Fh. Now consider the height from here to here. This is the rigid wall. This is x1, and if you want to calculate, so this is the projected area. So this is the curved surface here, and this is the projected area. So the height of the projected area, that is r, and depth is also there. Now, so from free surface here to here, center of pressure, the distance is h bar, and from free surface to center of gravity, that is x bar, that is equal to x1 plus r by 2. So this is the height of the projected area, so that is x1 plus r by 2. So this is the x bar. Now if you want to calculate the horizontal force, that is omega into projected area, just remember there is this curved surface have the projected area this. Okay, so you have to multiply it by this area, so r into width of the plate. So omega into AP into x bar. What is x bar? That is equal to x1 plus r by 2. So AP is the projected area. So this is all about the horizontal component. Now if you focus on the vertical component, so here this is the free surface here, and this is the rigid plate, and this is the rigid plate, and this is the curved surface here. Now G is the center of gravity. So here the vertical component act on centroid. So Fv, that is the weight of this liquid above the curved surface. Okay, and if the curved surface will be like this is the curved surface here, and here there is no fluid. So in left side there is a liquid are there. This is the free surface. This is the liquid are there. Okay, so what will be the vertical force? That will be, so here to here. So this is the red color projected area. That will be the vertical force. So vertical component act on a centroid G. So Fv, that is equal to mod of W. Okay, so if consider this is the rigid wall, and this is the rigid wall, and there is no fluid here, and here this is also the rigid wall, and up till that there is some fluid there. Now there is a curved surface is there, and if you want to calculate the vertical force, will be weight of the red color projected area. So weight of the red color projected area will be the vertical force. So vertical force, that is equal to weight of the red color projected area. So although there is no fluid is there, but you have to take the weight of red color projected area. So you have to find out the weight of this red color projected area up till this depth. So let's try to understand one question that is very important for gate point of view. A dam is having a curved surface as shown in the figure below. This is the dam here. So this is 20 meter which is given, and the curve equation is y equal to x square by 4. This is x direction, this is y direction. The height of the water by the dam is 20 meter which is given in this question. The density of water, that is 1000 kg per meter cube. Assuming G is the gravitational acceleration as 9.81 meter per second square, the horizontal force acting on the dam per unit length is. So you have to calculate the horizontal component. So how to calculate this horizontal component? Just draw the same picture here. So this is the center of pressure, which from here the horizontal force will act, and this is the center of gravity. Okay, now this is the projected area. So projected area will be 20 meter, that is 20 meter depth which is given in this question, that is 20 meter. So 20 meter and unit length is there. So the width will be 1 meter. So if you want to calculate the horizontal force, how will calculate that? So G equal to x bar. So up till G there will be distance x bar, that is equal to 10 meter. Because this is 20 meter, so 20 by 2, that is equal to 10 meter. Now this is the projected area. So area projected area ki what? 20 into 1. Okay. Now if you want to calculate the horizontal component, if you want to calculate the horizontal component, that is omega into AP into x bar, that is equal to rho g AP into x bar, rho that is 1000 into 9.81 into area of projected area, that is 1 into 20 into x bar, that is 10. So from here you can get the value of horizontal force, that is 1.962 into 10 to the power 6 Newton. So this will be our answer. Now next question, it is also very important question. So a horizontal oil tank is in the shape of a cylinder with hemispherical ends. If it is exactly half full, what is the ratio of magnitude of the vertical component of resultant hydrostatic thrust on one hemispherical end to that of the horizontal component? So what is given in this question? So this is the oil tank and this is the half full, okay, and the projected area. So here if you find the projected area of this surface, so this will be this is the projected area here. Now so G is the gravitational acceleration, G is the center of gravity and Cp is the center of pressure. So from here to here the distance will be 4r by 3 pi. Okay, so here to here the distance is r, which is given in this question. Now if you want to calculate the vertical force, okay, if you want to calculate the vertical force, that is omega into volume. Okay, so omega, that is omega into volume. What is the volume? That is 4 by 3 pi r cube divided by 4. So that will be equal to omega into pi r cube by 3. Okay, now if you want to calculate the horizontal force, so that will be equal to omega AP into x bar. Okay, so omega, what is the projected area, will be pi r square by 2. So this is the projected area. So pi r square by 2 into x bar, that will be 4r by 3 pi. So x bar, that is the distance from here to here, that is 4r by 3 pi. So from here you can get the FH, that is 2 by 3 omega r cube. So in question what is given, you have to find out the ratio of vertical force divided by horizontal force, that is equal to omega pi r cube divided by 3 divided by 2 by 3 omega r cube. So from here you can get the answer pi by 2. So pi by 2 is the answer. Now the next question, it is also very important question. So the horizontal and vertical hydrostatic force Fx and Fy on a semicircular gate having a width W into the plate of figure R. So you have to find out the horizontal force and vertical force. So what is given in this question? So this is the semicircular gate here, this is rigid and this is rigid here, and the width of the plate, that is the W. And here to here the distance is x bar, that is equal to h, and here the cross section, the projected area, that is the 2r into width, that is w, and D is the center of gravity and Cp is the center of pressure. Now if you want to calculate the horizontal force, that is omega AP into x bar, omega that is equal to rho into g, AP that is the projected area, that is 2r into w into 2r into x bar, that is the h. Okay, so from here you can get the horizontal force, that is 2 rho g h r omega. Okay, so this is the horizontal force. Now if you want to calculate the vertical force here, if you want to calculate the vertical force, so here there is a fluid in left side. So here this is the ABC, this is the semicircular gate. So on that there is a fluid there, and this is vertical force of that fluid, that is FV1. So if you want to calculate the FV1, that is omega into V1. So omega that is equal to rho into g, we know that. And what is the volume of V1? That will be. So this is the height. So what is the area of this? So here to here the area of h into r minus this area pi r square by 4 into w is the width of the plate. So from here you can get FV1. Now if you want to calculate the FV2, which is upward direction, so FV2 that is omega into V2. So rho g into hr is the total area plus, so hr is this area, here to here the area is h into r plus pi r square by 4 into w is the width of the plate. So from here you can get the vertical force, that is FV2 minus FV1, because FV2 is upward direction, FV1 is the downward direction. So FV2 minus FV1. So from here that is FV2, that is rho g hr plus pi r square by 4 into w minus rho g hr minus pi r square by 4 into w. So from here you can get the value of FV, that is pi by 2 rho g omega r square. So this will be our answer. So this is my handwritten notes. You can download it from the description. Like, share and subscribe my YouTube channel. Thank you.